our role here, with NDT and I'll even say propulsion, coming up with new propulsion health monitoring instrumentation techniques at the NASA Glenn Research Center, is to really develop a suite of instrumentation and techniques that will eventually be used on aero turbine propulsion engines to increase both safety and efficiency. So that's our main goal. Our main role is to support that. We develop the lower level TRL concepts to graduate these for actual use on an engine, and we work with our industry partners in doing that.
So really here is the initial step. It's a foundation, and later on we just take it further to the real application. Mark last year, went out to California and he was able to run a real test on a real turbine engine on an aircraft using the microwave sensor.
Right now we're looking at the NASA Glenn Research Center high precision spin rig. And what we use it for here is to do very low proof of concept testing on new types of turbine instrumentation and also new techniques for health monitoring of turbine engines. So what you're seeing here is we do everything on a subscale, again, just to validate new instrumentation, new techniques. This is a subscale, I'll say simulated geometry of a turbine disc that would be on a jet engine. This rig allows us to spin this disc up to 12,000 RPM, and we could try new techniques for structural health monitoring. The one that we've done recently is we've been looking at either the use of newer capacitive blade tip clearance sensors or a microwave blade tip clearance sensor in being able to detect to see if these could be used in order to detect cracks in a rotating disc. So what we have here is we have a disc that has a notch machined into it to simulate a crack, and we are running this through the full operational range, simulating the conditions that it would see in a turbine engine to see if these sensors were sensitive enough to detect the minute change in the disc center of balance based on blade tip clearance readings. That was one technique that we've been looking at recently. And again, other techniques that we've been looking at, along with just basic instrumentation, is also newer optical techniques. Are there ways that we could detect deformation of the disc? I mean, outright, obviously this crack is so big that you could actually visibly see it. But if it was small enough, we would actually start getting deformations and strains in the disc, and we're trying to develop techniques to optically measure that too. So we've been looking at many different concepts using this rig.
And typically what we do, we run tests with the baseline disc without any damage, and we compare it to a disc with damage. And that's how we base our analysis. Again, like Mark said, we use these type of sensors that they're supposed to act in a neutral fashion, and had they been placed in a turbine engine, an actual turbine engine, not to affect the performance of the engine in general. They just help assist us delivering a signal telling us whether there's a problem with the disc or not.
We're just one small piece of the work here. We do the foundational research, and then if it works, whether it's a new sensor, whether it's a new technique, or both, using a sensor and a newer technique, our whole goal is to just identify and make sure it works, and then we'll work with other people. There's other researchers here that will go to compressor, they have a rig that will simulate a compressor, a rig that will simulate a turbine, and we'll work with them to take that to the next step with the ultimate goal of testing it on an engine.
The sensors we talked about in our paper are non-contact sensors. They're not really sitting on the board of the disc or anywhere else. It's pretty much picking up a signal where we pick up where the signal is read, through our data acquisition system. And we monitor, how the vibration response, do take place while we're running while we're spinning the disc, and then after that, we just analyze these data and just try to put it in a meaningful format so we can tell, or we can, draw a nice and, a more precise conclusion about what did really take place and what the findings are.